This is a gate problem from analog electronics which appeared in the year 2022 for the Instrumentation Engineering paper. The problem is stated as follows. In the circuit shown, R1 equal to 100 kilo ohms, R2 equal to 1 kilo ohm. If the base to emitter voltage of the NPN BJT is 0.7 volt and the collector to emitter voltage is 5.2 volt, the beta, which is the current gain of the BJT, is dash. The answer should be represented by rounding off to 2 decimal places. So this is a numerical type question, and this is the corresponding BJT based circuit. So we can find that this is a typical collector to base resistor feedback type BJT biased circuit, and based on the information provided in the question, we can note down that this resistance is 100 kilo ohms. This resistance R2 is 1 kilo ohm. The base to emitter voltage drop is given by 0.7 volt and the collector to emitter voltage drop is given by 5.2 volt. Now note that this is the current which is called as the base current IB. This is the current that flows is called as the collector current IC, and so the current that flows from the top which gets branched into IB and IC must be equal to the emitter current IE, because IE is summation of base current and collector current. And then if we look at this part of the circuit, it is very easy to find out the value of IE using Ohm's law, because IE can be written as 12 volts minus of voltage at this node, which is 5.2 volt, divided by the resistance, which is 1 kilo ohm. So IE turns out to be 6.8 milliampere. Now if we frame the KVL equation for this part of the circuit, so going through this loop, we can write 12 minus of 1 kilo ohm times IE, which is the voltage drop across this resistance, minus of 100 kilo ohms times IB, which is the voltage drop across this base resistance, minus of 0.7 equal to 0. And then we already know that this voltage drop should be 6.8 volt. So going forward, we can write 12 minus 6.8 minus 0.7 equals to 100 times beta, 100 times IB, where IB is represented in milliamperes if we consider this resistance to be in kilo ohms. Therefore, solving for IB, we obtain IB to be equal to 12 minus 7.5 divided by 100 milliamperes, and this is equal to 4.5 into 10 to the power minus of 2 milliamperes. Now since our objective is to find out the value of beta, and we have already found out the value of IE and IB, we can use this relationship which relates IE to IB based on this ratio equating to beta plus 1, and therefore beta plus 1 being equal to IE by IB, we simply substitute the values of IE and IB derived earlier and come up with the expression of beta plus 1 being equal to 151.11, and therefore beta is equal to 150.11.